Hello everyone, I am Eren Güler and this is my ELE417 Embedded System Design class term project. Tripwire activated turret. There is an ultrasonic distance sensor which is mounted on a rotatable cover at the top of the casing. This sensor gets distance data in every degree in order to locate where object/intruder is. Above the distance sensor, there is a laser that aids pinpointing location where the sensor takes measurements. Behind the distance sensor, there is a servo control crossbow system that is again mounted on the rotatable top cover. When an intruder is detected, this crossbow shoots a 3D printed dart to the target in order to eliminate it. Additionally, an LCD screen is positioned outside the casing to provide the owner with information about the system status and operation. Inside the casing, we have all the wirings about the system connected to the main board. A servo motor regulated by PWM signals is employed to rotate the top cover, which the distance sensor and crossbow are mounted. Below the servo motor, we have our main board STM32F411RE nuclear board. Also, there is a buzzer installed to warn the owner when an intruder activates the tripwire. About 30 cm away from the main system, we have our laser tripwire system. This laser tripwire system employs a light-dependent resistor and a simple laser. When the light on the LDR decreases about a certain value, tripwire is triggered and the system starts the scanning area. Let's see all of the system in action. When the system powered up, first it samples the environment light and activates tripwire with this value. In this way, tripwire can operate in different places with diverse lighting conditions. After that, algorithm only checks for the LDR's lux value. When this lux value changes drastically, this means that something interrupted LDR laser beam connection by passing through it. Now, owner is alerted with a buzzer and program changes to scanning mode. The system's scanning mode focuses perimeter surveillance for detection of intrusion point. When an object breaches a 30 cm threshold, scanning stops and system switches to fire mode, preparing to fire the crossbow. In fire mode, the crossbow precisely delivers the dart to the target, making a direct impact. After completing its task, the system returns to tripwire mode and becomes operational after a manual reload of dart. In every step of this flow, startup messages, system modes, lux and distance values, messages related to operation are shown on a LCD screen to inform the user. Multiple demonstration videos are shown from different angles to ensure that the system works as intended.